Threadripper is not an EPYC processor. Different substrate, different dies. Two dies work, other two have no path to operation. Basically rocks. That's what James Pryor replied to my last AMD Threadripper, let's say, analysis video. So let's just travel back in time quickly and recap what we did so far on my channel. So the first AMD Threadripper video I posted on my channel was like half a year ago when the CPUs were not on the market yet. So we didn't really know how the AMD Threadripper looked underneath the heat spreader. We thought that it would contain two dies only because, well, it was the 1950X, which is a 16-core CPU. So we thought we would have two dies with 8 cores each. Turns out that when we deleted the CPU, we actually found 4 dies underneath the heat spreaders. So my theory was that AMD EPYC and Threadripper are actually the same and it's just a matter of core configuration. So then AMD replied with a statement and they said, no, that's not correct. 2 of those dies are dummy dies, they do not contain any transistors, and the 2 other dies are just normal Ryzen dies. So I went ahead and I made another YouTube video, which I'm sure you are familiar with, and the result is basically what you can see on the background of my screen in the back. So I took apart a whole AMD Threadripper 1950X just to check what the CPU actually looks like. So I had the substrate, I took off all 4 dies and I started grinding down the dies to see or to take a full die shot. And what I found was that all 4 dies contained transistors, contained 8 cores on each die. So of course my conclusion was that the dummy die statement is actually not correct and that we have actually 32 cores on each Threadripper CPU, no matter if it's a 1900X, 1920X or if it's a 1950X. Then James Pryor from AMD tweeted on Twitter that Threadripper is not an EPYC processor. It's basically the statement I read in the beginning, and that 2 of the dies are actually not electrically connected on Threadripper while all of the 4 are connected on EPYC. So the difference would be the substrate, the PCB. So that would be the difference between EPYC and Threadripper. To be honest, to me it didn't really make much sense. On a technical level, I would assume that you would just produce one substrate and you just occupy it fully all the time with 4 dies. And depending on what kind of CPU you need, if you need an 8-core Threadripper or if you need a 32-core EPYC, you just have a different die configuration. So how do we prove that? It's actually not that easy, but there is a way to do it. But to do this, I had to invest money again. So I went out and bought an AMD EPYC 7251, which is basically the cheapest EPYC you can find. It's the 8-core version, 16 threads, 32 megabyte of L3 cache, 120 watt TDP, 128 PCI Express lanes, and has a base frequency of 2.1 gigahertz and a turbo boost of 2.9 gigahertz. So my idea was to compare this CPU to the 1900X, but back in the days, actually I bought those CPUs already almost 2 months ago or 1 month ago, and back then the 1900X was not that available, so the availability was not that great. So I went out and bought a 1920X, which from my theory should still be the same, because I think all of those CPUs are the same and it's just a different die configuration. So the 1920X is basically the 12-core, 24-thread CPU, and it's not really different. So if we compare the Threadripper 1900X to the EPYC 7251, the basic difference is that the Threadripper has only 16 megabyte level 3 cache, while the EPYC has 32 megabyte level 3 cache, and TDP of the Threadripper is a lot higher. Obviously that's mainly because of the frequency, because frequency of the Threadripper is like 3.8 gigahertz base and 4 gigahertz with XFR. And also the Threadripper has only 64 PCI Express lanes, while the EPYC has 128 PCI Express lanes. You can actually tell by the fact that the Threadripper has 64 PCI Express lanes and EPYC has 128 PCI Express lanes that the die configuration has to be different. So Threadripper is using 2 dies while EPYC is using 4 dies. So the configuration of this 8-core CPU would be 2 plus 2 plus 2 plus 2, means that of each die we're only using 2 cores. Comparing that to the 1900X, which is also the 8-core CPU, we would use a 4 plus 4 configuration, and that's the reason why we only have 64 PCI Express lanes. And on my last video, I had a lot of comments saying it can't be the same because the socket is different, but the socket is exactly the same. So you can already tell this is the Threadripper CPU, this is the EPYC CPU. If you just compare it, it's exactly the same mechanically. Even the small cutouts you have in the PCB on the side to align it into the socket are exactly on the same position, which is kind of obvious that it's exactly the same socket. And I even checked the pinout of both CPUs and it's exactly the same, apart from that on the Threadripper you're lacking the PCI Express lanes and the memory channels. So on the position where the PCI Express lanes and the memory lanes are located on the EPYC CPU, we just have reserved pins on the Threadripper CPU. One difference I noticed is that the capacitor placement on the back is different. So we have some SMD caps on the back and the placement is different between Threadripper and EPYC. However, that does not necessarily mean that the CPUs are different, because placing some caps on a different position is not really an issue. You can still manufacture the CPU exactly the same, and just in the end you place the capacitors on a different position. Of course, it's not going to be very easy to analyze this and to look inside the CPUs, but there is a way, and the first thing we have to do for this is delete both CPUs. So basically, I will take the EPYC CPU and also this beautiful Threadripper CPU and delete both of them. So the first thing I will do is cut around the IHS with a razor blade, basically to loosen the glue that's going around it. We already know that there is a stripe of glue in between, so there's actually a big surface area which keeps together the IHS and the PCB, which makes it kind of hard for deleting, especially keeping in mind that the CPUs are also soldered. So we have 4 dies that are also soldered to the IHS. So I found the easiest way for deleting is basically loosen the glue, then put it inside a deleter, inside the oven at like 180 degrees Celsius for an hour, and then basically just delete the heat spreader. Deleting is the same as previously. I had to make a new deleter because I borrowed my old one to Linus Tech Tips, because he did a video where he swapped the IHS of his media sample to a retail Threadripper CPU. So yeah, basically it's the same principle. I will just put in the CPU and I have this slider which is pushed by the screw from this direction, and then it's just moving off the IHS. It's quite simple. So I will just put the 2 CPUs inside the oven now and delete them. So I'm finally back, and it's been like 4, 5, 6 weeks. I'm not exactly sure how long it was since I've been working on this project. By total project time is already like 2 or 3 months. So the last thing we were talking about is that I wanted to delete the AMD Threadripper and the AMD EPYC CPU. So the first thing I had to do, as I said before, is prepare the deleting, and that means for the AMD Threadripper and the EPYC CPU, I have to take both and go with a razor blade really carefully around the CPU first. I'm not really a fan of this whole razor blade method, as you surely know. And the reason is that whenever I do it, I always accidentally cut into the PCB. It happened again to me this time. I think in the Threadripper CPU I slightly cut into 2 of the edges. It's not really a problem for this analysis video, but I'm not sure if the CPU still works, but that's okay. We can still use the CPU for what we want to do. So in the next step, we treat our Threadripper like a pizza and put it into the oven at like 200 degrees Celsius and leave it in there for like 45 minutes, which would be a bit too long for the pizza, but it's perfectly fine for the AMD Threadripper CPU. So when I take it back out of the oven, it's usually like 180, 185 degrees Celsius, because I always keep track on the temperature of the CPU with a thermometer. Then I put it here on my desk, and the CPU usually then has around 170 degrees Celsius. And then the only thing I have to do is just use the screw and apply pressure onto the IHS until the IHS gets loose. It takes a little bit of pressure, but usually not that much, because we already loosened the glue on the sides. And then just take the knife and slide off the IHS. And as you can see, it's the same as what we've seen before with the 1950X. Still the same, 4 dies are underneath there, the caps, everything looks exactly the same. So let's go over to the AMD EPYC CPU. Same procedure as before, just put the AMD EPYC into the oven, take it out at like 180. When I put it on the desk, it has again like 170 degrees Celsius, and then just apply pressure again, and it's basically exactly the same as with the Threadripper CPU. I think this is the first time that somebody deleted an EPYC CPU. I haven't seen any EPYC deleting before, but I was pretty sure that it's exactly the same underneath as the AMD Threadripper CPU. And again, you can see once I took off the IHS, they look kind of the same. I'm already saying kind of the same because they're not exactly the same. So you can see 4 dies, you can see all the caps around there. The CPU was not really damaged, so everything went fine and smoothly. So let's go over to the analysis. So before jumping into any conclusions or anything, I can already tell you that this video turned out to be much different but kind of more interesting than what I thought it was. So let's take a look at this picture. It shows the AMD Threadripper on the left and the AMD EPYC on the right. And just by looking at this picture, you can straight see that the CPUs cannot be the same. So top left corner on the Threadripper, we have this small resistor. It could be just a bridge resistor, like with a 0 ohm resistor. I'm not sure what it is. Didn't have time to check that. It doesn't really matter anyway. But if we check the AMD EPYC on the right, you can see there is no such resistor. And just comparing the top left side with a triangle here and this small dot here, if you go over to EPYC, there is no dot. The dot is on the right side. Same on the bottom. It's kind of inverted. So this spot is on bottom right on Threadripper and it's on bottom left on the EPYC. So we can already see that the CPUs cannot be the same. So the substrate, the PCB, is 100% not identical. We can zoom in to the CPU PCBs, and if we compare the edges on the bottom left, you can see the Threadripper is marked with 32200 and the EPYC is marked with 32188. Not sure what exactly this code means. It could be whatever code, but turns out that all the Threadripper CPUs I had 32200 as a code, and I assume that EPYC just has 32188, but I could be wrong there. That's just an assumption. So we already know that AMD Threadripper and AMD EPYC are not the same CPU. So going back to the statement from James prior, the question is, are 2 dies electrically connected or are 4 dies electrically connected on AMD Threadripper? To figure that out, the only thing we can do is an X-ray analysis, and that's what I did. So I basically cleaned my CPUs and shipped them into a German company, and they do PCB analysis with X-ray. So let's go over that footage. So that's an X-ray shot from the top on the AMD EPYC CPU, and it's very hard to see anything, to be honest. The problem is that those CPUs have so many layers that it's really hard to judge where the traces go and where the traces are even located. But one thing we can do is we can double check this picture with this picture I have found on the internet. So basically, not sure where it was shown or where it was leaked, it doesn't really matter. But what we can see is that we have the 4 dies. And then we have all those traces, and those should be the interconnects between the dies. So if we could just take a look at the top part, just remember where the traces go from the top right to the top left chip and all those traces here on top. If we just compare this to the X-ray picture, we can see that this is the only area where no vias are located. So all those small black dots here, those are vias. Vias are basically small connections inside the PCB, usually connecting different layers, or you have, for example, a ground layer and another ground layer, and you just connect those 2 ground layers with a via. And as I said before, this area where no vias are located exactly matches with the picture I showed you before, where we saw all the traces going from the chips to each other, well, the interconnects between the chips. So my assumption would be that all the areas where we don't have those vias going through the entire PCB, those are the areas where we have the traces going from the chips to the other chips, like basically the interconnects. This picture again shows the AMD EPYC CPU kind of a little bit angled from the side, and what we can see here are very, very fine traces that go from the top right die to the bottom left die, and that's just an example of how fine those traces are. So it's really difficult to see them when you take a look from the top, but just remember this picture and we will take a look at a kind of a similar picture from AMD Threadripper and just compare it. But before we go over to that, we simply just take a closer look at the EPYC again. So this is a picture from the top left. As you can see, this is the die, and you can see all those very fine spots here. Those are the solder bumps that are basically connecting the die to the PCB, and this way we can judge if the die is, well, electrically connected to the PCB or not. All those black squares you can see here, those are the MLCC caps that are either on the front or on the back. So those here on top and on the left, they are located on the front of the PCB. Those in the middle or the bottom right corner, they are located on the back of the PCB. It's the same if we just go over to the top right chip or the bottom left chip or the bottom right chip. As I said before, if you want to take a closer look at those pictures, feel free to download them from the description. You can just take a closer look at them. Take your time. It can be very interesting. Maybe you can find something else and just put it in the comments. So let's go over to the Amd Threadripper and the more interesting part from my point of view. So as I said before, we can kind of judge from the location of the vias where the traces are located. So again, very similar to Amd EPYC. On the top part here we have no vias, and this should be the area where we have some kind of traces or interconnects between the dies. And we have the same like in this area here, or in the area on the bottom. So all of those places could be traces or interconnects between the dies. If we take a look at this picture, it shows again an angled shot from the side, and you can see all those very fine traces going from the top left die to the bottom right die, and you can see they're extremely fine. So as I said before, it's really hard to see, but even if we just check on the top right and bottom right die, you can see some traces going in this direction, and you can also see some traces going in the bottom left direction. Again, this is also an angled shot from a different position. Again, we can see a lot of traces going from the bottom left chip to the top right chip, and we can see some traces also located here. So it's pretty safe to say that all 4 dies are electrically connected. So you might think, why does it even matter, or what's the point? Why does it matter if there are only 2 or 4 electrically connected? So basically, just judging by the facts, we know for a fact that Amd EPYC and Threadripper are 100% not the same CPUs. So for EPYC, everything is perfectly fine. We know that all the 4 dies are always used just because you need all the PCI Express lanes, you need the memory controllers and all of that. So all of that is totally fine. For Amd Threadripper, we know that we have 4 dies on there. For the 8 core, for the 12 core, 16 core, and so on, we only use 2 dies. So why are there 4 dies on it? I can already tell you that mechanical support is completely the wrong answer. Just don't believe any of that. That makes no sense whatsoever. If you would tell me that you would put 2 additional pieces of silicon on a PCB for mechanical support, that's the biggest waste of money I have ever seen. You would rather modify the IHS and just add some of those stripes in different locations where the dies are, instead of just placing dies there. So the mechanical support reason is it makes no sense whatsoever. So there's another option. It's a fairly complicated and difficult option, let's say like that. I don't believe in it. I'm clearly saying that I don't believe in it. I'm just saying that it's kind of possible. So if you produce CPUs, you have the wafer, and then you get all the chips out of it. You have your yield rate, which basically means how many chips out of the wafer you can use. Some of them are broken. They're not good, so you cannot use them. One thing you could do, so you take your Threadripper CPU, you only need 2 dies, but you add 4. 2 of them are broken, you add them. That means that they don't really count as broken dies on your yield rate. So it could kind of mean that AMD is faking the yield rate just by selling those AMD Threadripper CPUs. As I said before, I don't believe in this option, so I don't want to see any quotations out there in the internet quoting me on that, because as I clearly say, I don't believe in it. What I believe in is the third option, and the third option makes a lot of sense to me. So the third option is that AMD is going to release a 32-core AMD Threadripper CPU, and it's very possible. So as I said before, AMD socket for EPYC and Threadripper are exactly the same. You can use an 32-core Threadripper CPU with 4 memory channels and 64 PCI Express lanes. You don't have to change anything. You don't have to change the socket. You don't have to change a motherboard. You don't have to change anything. All they have to do is modify the microcode or whatever they do to differentiate those CPUs. You only have to change that, and you can have a 32-core Threadripper CPU without doing any additional development. We don't have to do anything. So just judging by the facts, just judging by what we see here, the only possible option I see is that AMD is guaranteed releasing a 32-core AMD Threadripper CPU. Infinity Fabric clearly allows that you can use 4 dies but only use memory controllers of 2 of the dies, and only PCI Express controllers of 2 of the dies, and the other PCI Express controllers of the other dies are just used for the communication between the dies. Everything like this is completely possible, and that's the only thing I see what could happen. So as I said before, yeah, AMD is going to release a 32-core Threadripper CPU. So let's see what time brings. Yeah, was very interesting to see this video. The outcome was completely different from what I expected. A lot more interesting than I expected. I hope you also enjoyed this video. Leave a thumbs up if you liked it. If you have any questions, recommendations, whatever, leave it down in the comments below. Check out all the pictures. You can find them in the description. Otherwise, enjoy the rest of your Sunday. See you soon.